Ever felt completely lost when trying to understand web servers? That was me a while back. But today, I'm going to explain it in the simplest way possible, using NGINX. Stick around and by the end, you'll have a solid grasp of web servers. A web server is a system designed to deliver web content, such as web pages, to users over the internet. It processes incoming requests from clients, typically web browsers, and responds by serving the requested content, which can include HTML pages, images, videos, and other files. Web servers are essential for hosting websites and providing online services. The key components of a web server: hardware. The physical server that stores the web content and runs the web server software. This can range from a simple personal computer to a powerful dedicated server machine. Software. The web server software, such as Apache or NGINX, that handles HTTP requests and responses. It interprets URLs, processes requests, and serves the appropriate content. Operating system. The underlying system software that manages the hardware and runs the web server software. Common choices include Linux, Windows, and Unix. Protocol. The web server uses the Hypertext Transfer Protocol, HTTP for short, or its secure version, HTTPS, to communicate with clients. How a web server works. First, an user enters a URL in their web browser, which translates to an HTTP request sent to the web server. Then, the web server receives the request, processes it, possibly interacting with databases or other services, and sends the appropriate content back to the client. It can be an HTML page, an image, or a video. As the third step, the web browser receives the response and renders the content for the user to view. It's so simple, isn't it? Web servers can be static or dynamic. Static web servers serve fixed content, such as static HTML files, images, and videos, without any server-side processing. Dynamic web servers generate content dynamically, often using server-side scripts, for example PHP, Python, or Ruby, that interact with databases to create web pages on the fly. The most common web server software are Apache HTTP Server. It's one of the most widely used web servers, known for its flexibility and robust feature set. NGINX, known for its high performance, stability, and low resource usage, often used as a reverse proxy or load balancer in addition to a web server. Microsoft Internet Information Services, IIS in short, a web server for Windows servers integrated with the Windows operating system. Web servers play a crucial role in the functionality of the Internet, enabling users to access web content and services. Understanding the components, workings, and types of web servers helps in choosing the right server setup for different needs and ensures effective and secure web hosting. To understand this concept better, let's create and set up a web server by ourselves using NGINX. We are going to use Docker to simplify the setup process. First, we have to connect to a Linux machine by SSH. In my case, this is an Ubuntu server running in my local network, but feel free to use any server in the cloud or just a virtual machine, or even your local machine if you want. To authenticate, we just provide the username and the password, and basically we are in. The next step is to create a working directory for our web server. So let's make a new directory by executing sudo mkdir /p/var/www/nginx.local/, where nginx.local is the domain name for our web server, and it's good practice to call the working directory in the same way. Let's create a folder for images that will be served by our server, and let's download an example image from the internet. Now, it's time to create HTML files that will be served by our server. First, let's make a directory for them. Now, let's create a simple index.html file. I'm going to create this file using Vim, but any other text editor like Nano or just V will be fine as well. Then, let's create a file for our error page, simply by copying index.html and changing its content to fit our needs for this case. Now, let's switch to our main directory and create a new folder called NGINX, where we are going to put a configuration file. Then we create the proper file that contains configuration for NGINX and is used to define how NGINX should handle HTTP requests. Server block defines the server configuration. Everything inside this block pertains to how NGINX should handle requests for a particular server. Using listen directive, we tell NGINX to listen for HTTP requests on port 80, the default port for HTTP. Next, let's define the server name. When a request is made to nginx.local, this server block will be used. Later, we will set up a local DNS to simulate the real-world scenario, where we will try to access a web server that is hosted on one machine from another client machine. Now, let's specify the document root, the directory that contains the files to be served. It's a location in our NGINX container where a bit later we are going to copy our custom HTML files. Index directive specifies the default file to serve when a directory is requested. It means that when a request is made to a directory, NGINX will look for the index.html file in that directory to serve. This location block defines how to handle requests to the root URL. Inside the location block, we add try files directive. It checks for the existence of the requested URI, file or directory, where equals 404 means if neither the file nor directory exists, the web server returns a 404 error. Next location block directive defines how to serve images. We set it up similarly to the previous one. Error page directive defines a custom error page for 404 not found errors. So when a 404 error occurs, NGINX will serve the 404.html page from the document root. Another location block defines specific handling for requests to 404.html. The internal directive means that the 404.html page cannot be accessed directly by a client. It can only be served internally by NGINX when a 404 error occurs. So, to wrap it up, this configuration sets up an NGINX server that listens on port 80 for requests to nginx.local. When a request is made to the root URL, it tries to find and serve the requested file or directory, returning a 404 error if not found. A custom 404 error page is defined and marked as internal, meaning it can only be served when a 404 error occurs and not accessed directly by a user. This configuration provides a basic yet functional setup for serving static files, with a custom error page for not found errors. Next step is to make a Docker file for our NGINX container. Let's use the latest official NGINX image. Also, we have to remove default web server configuration. But instead of it, let's copy our custom configuration file into a Docker container. Next step is to copy our HTML files into the Docker container to the root location we already defined in the configuration file. And we want to do very similar thing for the images. Now, let's build a Docker image for our Docker file by executing the following command. Now, it's time to run the container using docker run command. We want to run this container in the background and map port 80 of our host machine to port 80 of the container. Let's check with docker ps command if the container is up and running, and as we can see, it is. So it's time to open port 80 on the server machine to make it accessible from the outside world. We can achieve that by typing sudo ufw allow 80/tcp. The last step of the setup process is to extend the etc host file on our client machine to access our server by the domain name we already defined. In the real world, you want to configure a DNS for the server, but locally we will do it as simple as possible. So let's head up to the another terminal and open the configuration hosts file. Then let's add a new record at the bottom of it, where first goes the IP address of the server and then the domain name. And that's it. Let's try to access our server from a browser. It's up and running. As you can see, it serves index.html as a root page, so let's try to access a file that doesn't exist. We can see that the 404 error file has been loaded as we expected. The same for images. In this video, we've covered the fundamental concepts of web servers and demonstrated how to set up NGINX, a powerful and widely used web server. By understanding the key steps of configuring NGINX, you are equipped to create a robust web infrastructure that delivers fast, secure, and scalable experiences to users. Remember, mastering web servers is essential for anyone involved in web development or server administration, as it lays the foundation for building reliable and efficient web applications. Now that you've learned how to set up NGINX, I encourage you to try it out yourself. Experiment with different configurations, explore advanced features, and don't hesitate to reach out with any questions or feedback. Additionally, be sure to check out my other tutorials on related topics to further expand your knowledge and skills. Happy coding and see you in the next one.